Many of you in the room, of course, will already know Shara, and I'm just speaking into this microphone so our web streaming people can hear what I have to say. Shara is a well-known technologist, futurist and opinion leader in the Australian telecommunications market, the founder and CEO of Market Clarity, an award-winning telecoms analysis firm, and we'll be getting the benefit of that work that Shara does in her commercial life in this afternoon's presentation. So Shara's most recent research area involves mobile broadband network performance measurement and analytics. So it's very pertinent to our discussion. But previous work has looked at infrastructure and services, prices, plan features of consumer fixed and mobile broadband services, consumer broadband download behaviour, and NBN wholesale pricing, amongst many others. So we will look forward to Shara's presentation.
And Rosemary, thank you very much for your kind introduction, and I'd like to thank the ACMA for inviting me. A lot of the discussion this morning has been on mobile apps, and in particular apps that measure mobile broadband. That's the subject I'd like to cover this afternoon. And there are just a couple of things that I want to go through. First is the kind of information that consumers are able to get in Australia today. Secondly, a little bit about mobile apps, some of the major ones that are out there, and a bit of analysis on how they compare and contrast. Then a bit on what the US government is doing with respect to mapping mobile broadband, and some closing thoughts on what we can do here in Australia. So first, we've talked a lot about carrier maps. This is something I grabbed of Telstra's just a few days ago, and what I wanted to do by showing you this map in the next view is compare the different kinds of information that carriers make available in their maps for us. So in this Telstra map, we see that there are color shades that indicate speed. You get typical ranges. For instance, 4G would range from 2 to 40 megabits per second on the downstream. That's quite a big range. But at least it is a range that consumers can relate to. It's something that they understand, maybe not in technical detail, but they understand 40 megs is a lot faster than 2 megs. This is an Optus screen grab. I've got a couple here. And with Optus, the map that has the yellowy bits is showing 3G dual band, and the map that has the green bits is showing 4G. In contrast with Telstra, Optus maps show technology available on an indoor, outdoor, and antenna basis. There are no typical speeds shown here. Optus does not also distinguish between voice and data. Forgot to mention when I was showing you the Telstra map, you can toggle between voice and data coverage. For a typical consumer, they've heard the terms 3G and 4G, but my view is they probably don't understand all the nuances. I think a lot of us in this room may not even understand all the nuances. This is a Vodafone map, and on the Vodafone maps, they show availability on an indoor and outdoor basis. Once again, there are no typical speeds shown, and Vodafone maps don't distinguish between voice and data coverage either. So the consumer is faced with three different kinds of maps when they're looking at what service they ought to look at in Australia. However, you can zoom down and look at your address and get some good information. Now, when we look at the whole issue of mobile broadband speed, there are a couple of things to bear in mind. And we've talked about it this morning by a number of presenters. But basically, the signal strength can fluctuate very, very widely depending on the number of people that are using the service at a particular point in time, interference, the time of day, what kind of handset someone is using, how a carrier dimensions between voice and data, a whole range of different things. When you're looking at mapping, one of the things to consider is how many tests are required in order to have a statistically valid sample. Is one drive test enough to actually say, well, I'm going to get 10 megabits per second in this area? Are 10 drive tests enough? Are 100? How does that relate to a typical customer's experience? We've also heard quite a bit about how carriers and vendors and others, including many of the states in the US, in their mapping program, model the expected mobile coverage based on a whole range of technical parameters, and it's quite a complex mathematical discipline, and it has a role in mapping, for sure, and in generating expectations of coverage. But is it the same, I pose a question, as actual user experience? And I'll show you some pictures a little bit later on. Is it enough to actually frame consumer expectations? And once again, how do you rank speed? What's fast, what's not fast? So in the US, the FCC has defined a range of bands for broadband speeds. These bands apply equally to fixed broadband as well as mobile broadband, and they start with first generation broadband of basically 200 kilobits to 768 kilobits, and they go all the way up to what they call broadband tier 7, which is greater than 100 megabits per second. Here we're talking about the downstream speed. Now, clearly this isn't the mobile network of today, although we're getting up there. One of the vendors that I'll be showing you in terms of mobile apps, a vendor called Mobile Pulse, has basically taken this FCC scheme and assigned A to F ratings that use this scheme as the basis. Essentially, for anything that's over 3 meg, they consolidate it into the A rating because that was equivalent to roughly a 3G A rating. The scale that they use is editable, so you could actually define different scales for 4G and 3G. It's one way of classifying it, and they use color codes and letters to try to make it understandable to someone who's looking at this. So some of the apps that are used. I had mentioned I'll be discussing a bit about what the US is doing with broadband mapping, and I've selected 8 apps that I'll talk to you about today in not a lot of detail, but just by way of comparison. These apps are in use by different states in the US, so I'll just go through quickly what they are. Going clockwise, starting at the left, we have an app that was mentioned previously, Ookla, which does the speedtest.net app. It's quite popular. It runs on Apple, Android, and Windows. Going clockwise, the next one is something called RootMetrics. This runs on Apple and Android smartphones. Going around towards the bottom, we have OpenSignal, which runs on Apple and Android. And then we have Mobile Pulse, which is the far left, and that runs on Apple, Android, BlackBerry, and Windows. Some more that are in use in the US and elsewhere. The first one is an app that was custom made for California, but it's relevant to the discussion, so I thought I would put it up here. It's called CalSpeed. The next one is an app called Sam Knows. It was something that was developed for the US government, and I understand there's going to be an announcement tonight about a newer version that's coming online. That one runs on Apple and Android. Forgot to mention CalSpeed runs only on Android. And going around towards the bottom, we have Sensorly, which runs on Apple and Android. And we have another app called My Mobile Coverage that runs on Apple, Android, and BlackBerry. So, what are the things that you would look at in an app to compare and contrast? The first, and what I think is probably the most important, is whether the testing is done on a manual basis or an automated basis. In the first instance, to get an app on a device, a user self-selects. They decide that they want to download something on their device, or if it's an enterprise, it may be that the enterprise decides that they want to load it on a device. So you have a certain amount of self-selection there. Secondly, most of the apps on the market require you to hit a manual speed test button, and generally people will do that maybe if they're playing around and curious, but usually when they're unhappy. However, there is an alternative, and that's automated testing, and it can be done either on a continual basis, like when you're drive testing, or on an automated basis, say once an hour, once a day, twice a day, whatever an admin decides to configure. Another consideration, particularly for consumers, is data usage monitoring. In my view, I haven't seen apps that actually tell consumers how much data they're using by playing around with the speed testing. With customers that have plans with low data usage allowances, that's really important because they might end up with bill shock. So having some sort of either monitoring or threshold in the app, I think, is important. Another issue for consumers is battery level monitoring, or perhaps setting limiters on how much battery the app is going to use, especially if you're doing something like automated testing. You don't want to find that you're out and about, you need to make an emergency phone call, and the silly speed test app has drained your battery completely. That's not a good result for a consumer. The next area is what sort of metrics are captured. Generally, all of the apps will measure up and download speed. They'll generally all measure latency. A couple will measure delay variation or jitter, which is interesting for real-time video or audio sometimes. Packet loss is something that's very rarely captured, but can be. Signal strength is interesting. You know, we tend to think of signal strength as the barometer of whether we're going to be able to get a connection and do something useful. But how many times have you actually had your phone in your hand, you see 5 bars, and you're trying to get a Google map and you can't get the map, or you're trying to send an email and you can't get something through? So signal strength in and of itself is not an indicator. One of the other issues with respect to measuring signal strength is that Apple, which has a very, very large market share, does not pass RSSI, which is the signal strength techie term, in its API. So unless you actually jailbreak an Apple device, an app developer can't get at it. So what you would find is developers will measure signal strength in the Android version of something, but maybe not in the Apple version of something because they can't get it without doing something bad. Another thing to look at in apps is whether they allow the consumer to report problems. So if something goes wrong, you know, does it automatically get reported? How does it get reported? Some of them have the ability to, you know, push a button and tweet, you know, or push a button and send something to a carrier. There are different ways that the apps do this. Some of them don't do it at all. And when you do that, does it go to a carrier, someone else? Where does it go? Another differentiator in the apps is whether or not they map inside the app themselves or whether there's a separate portal. And if there is a web-based portal, is it something that's available to the public, or is it available only to the provider of the app, or perhaps an enterprise that might subscribe to a service, or a carrier or other organization that might buy data from these app manufacturers? And last but not least are privacy considerations. First off, is there any sort of privacy documentation with the app? Do you even know what's collected? And if you do know what's collected, is there any information that could identify you as an individual consumer? And what I'd like to do next, being a bit of an analyst, data geek, couldn't help but throw together a spreadsheet and do a bit of a compare and contrast with these 8 apps. So there were 8 apps that I looked at. 7 of them run on iOS. The one that doesn't was CalSpeed because it was designed only for Android. All of them run on Android. 2 run on BlackBerry, 2 on Windows. Looking at some of the metrics, all of them measure up and download speed. 6 of them measure latency. 1 each measure delay variations and packet loss. 3 of them measure signal strength. 5 of them map in the app, and 6 of them map in a portal, which may be public or private. What I should say with respect to metrics is that what you see in the app isn't necessarily all that's collected by the app. It's just what you as the consumer can see. And I don't have the ability to look at the back end of all of these apps. And last but not least are some of the design parameters. Is it an automated speed test or is it manual only? In my finding, the only one that did automated was Mobile Pulse. Are there data usage monitoring or constraints? Only 1. Battery level monitoring. Do they measure cell and Wi-Fi? All of them measure cell, 6 of them measure Wi-Fi. How many had a privacy policy? 6. In my view, how many were actually collecting private data or suspected private data? I'd say 4. The mobile apps use different testing methodology. I'm not going to go through this entire chart, but just to give you a view on some of the complexities of this discussion, one of the things that differentiates between apps and how you might get different results from different apps is how many HTTP threads are they using. So if you're using a browser, it would typically have multiple threads, and apps like CalSpeed and Ookla use 4 parallel threads. Whereas if you're doing enterprise-type applications like downloading a document, they would use 1 thread typically, and apps like Mobile Pulse and others use 1 thread. And it depends on who the target market is as to which of these parameters a particular app designer might decide to use. Another important aspect is, are you discarding data? Some of the apps that I looked at actually discard anywhere from the 15 to 30% of outliers, but you're actually discarding valuable tests which show a view of how well the networks are performing. I think you need to show the good as well as the bad, and in my view, you need a lot of samples to be valid. There is, however, work in the IEEE 802.16.3 committee, which is the committee that is looking at mobile broadband network performance measurements, and Mobile Pulse is actually sponsoring that, so there is some hope for standardization in the not-too-distant future. So the U.S. Broadband Mapping Initiative, very briefly, 2009, U.S. government allocated $293 million. Every single state and territory got to get their grab of that pie. Every one of them used slightly different methodologies. Surprise, surprise. Generally, it goes like this. They ask the vendors, that is the carriers, to supply them with information either in shapefile format, Excel format, or a combination. They then map it to U.S. Census blocks and create maps. They then try to validate the data through a variety of mechanisms, including things like drive test, doing statistical modeling, crowdsourcing data, and buying data from the map applications that I showed you before that run on smartphones. So here's an example, Utah. They took primarily a drive testing validation methodology. They looked at 6 carriers. They drove over 6,000 miles. And by the way, every one of these 6 carriers also did the same drive test. Nobody will share data because they all think it's proprietary. The state shares it with the carriers, but not backwards. And estimates from some of my colleagues in the US say that they figure each drive test runs anywhere from $60,000 to $85,000 US, and they do this every 6 months. California, as I mentioned, they designed this custom app. In the US, they're doing updates to the mapping portal every 6 months. The last update was December 2012. In California, they use the GIS or tabular data. Then they also do the statistical modeling. Then what they did is they partnered with one of the universities, developed this app, and then paid students to go out and do drive testing for them. Last year in 2013, they also released a public crowdsourced version, and that's where you see the pretty pictures from. In the December 2012 version, California, which has some really cool stats that you can download, they had a spreadsheet that I downloaded that had 9,800 test samples with all kinds of good stuff in it. So that was the results of the drive testing. And this is just a picture of the California map. Oh, by the way, in addition to the U.S. portal, with this grant money, every single one of the states has developed their own mapping portal, and they're all different. Surprise, surprise. Here's another example. This is Delaware. Their online mapping portal was not working very well when I tried to do a screen grab. None of the things actually would display anything useful, but they do a lot of desktop study. They did limited drive tests. They spent 5 days in the field. They went to 46 locations and did 110 speed tests. They also have a web app that people can do speed tests from a browser, but it let me do a test from Australia on DSL pretending that I was on a mobile connection, so I hope they discarded it. A number of the state governments are using Mobile Pulse and doing crowdsourcing. They like it because Mobile Pulse does automated testing, and they've got a private mode that basically doesn't collect any consumer data. And they also deploy it in enterprise mode, and it goes in police department cars and fire trucks and things like that. They love it because you get really, really large samples because of the automatic data collection. And the same methodology is also used, by the way, by a lot of the large drive testing companies. They use it because it can run in continuous data collection mode. This is a screenshot I grabbed of the last 6 months from Colorado, and I've zeroed in on just one light blue grid. In that light blue grid, in the 6-month period, there were close to 55,000 test results. that's a lot. You know, when you compare that to like 9,800 for the whole state of California, you start to understand why you would want to look at crowdsourcing on automated scale and on a large scale. It gives you a lot of data. Conclusion of the US. Well, this is right from the US mapping portal, and what it's showing is a view of reported speeds by the carriers versus the actual speeds reported by all the different states using all the different methodologies that, 50 states and 6 territories can think of. The green indicates that the reported speeds were faster than the carriers indicated. The red indicates slower speeds than the carriers reported. I'm not making this stuff up. You can look at it online. The URL's right there. So, what are the implications for Australia? Well, the US government provided grant funding to the states to collect and map fixed mobile broadband performance data. A range of methodologies were used. You can argue that that's good or bad. One of the interesting things, though, is that the carriers were cooperating with the states. They provided GIS files, they provided Excel files, they provided a lot of data, and generally, because the states also provided the information back to the carriers, they found it a very useful cooperative process. Could a similar program work in Australia? Gut feel is I think it could. But consumer privacy issues are really important, and I think that needs to be considered in any program. There certainly needs to be a large enough data set, big crowdsourcing initiative to make the sample valid. Consumer data usage and data usage protection is another important issue. We wouldn't want to see, millions of Australians download these apps onto their smartphones and suddenly get bill shock because they're doing the good thing. There are a number of methodology issues that I think remain unanswered. For instance, how do you represent data sets with variable results? Well, probably taking averages. If you have a large enough data set and you start looking towards averages or means or rather towards medians, you're probably all right. But there are variations, and maybe you have maps that show time of day. Would carriers cooperate? Probably, maybe. I guess that's a question for the carriers to answer. And one thing I would say, based on spending a lot of 2013 looking at this issue, is that I wouldn't recommend, sort of consolidated mapping just based on theoretical potential maximum speeds, because real speeds vary for all the reasons that we've heard about today. And I think something like a consolidated map that shows real-world results could provide some very useful information to consumers. Ladies and gentlemen, thank you.